Hello, everybody. Happy Monday. Thank you very much for joining me today. Really sorry that we are half an hour later today. I had something I had to put earlier today. So this isn't a new thing. We will stick to our regular 4 p.m. UTC slots. But we're a bit later today, but hopefully we're going to have a bit of fun. So if you have to drop off early, not a problem. As you know, we have these videos on YouTube. I'll update the article that we've been working on and what we're going to be doing today. So for those of you who were here last week, what we did was we picked some data. So I can't remember who it was. I'll have to look up my notes, but somebody suggested we have a look at some retail data. So that was a great data set and we had a bit of fun with that. So if you recall last week, we took that data, we talked a little bit about how we'd go about modeling it. So we did the modeling together. We then imported the data. So we talked about importing that data. We did a few queries. That was all good fun. So what we're going to do is I think we've got a little bit more we're going to spend on there. So we'll have a look at the data model in a bit, but I think we can refactor that data model because there's some interesting questions that we can ask. So we're going to be doing that, and then that'll wrap it up. So I'll update the impromptu blog post. I'm going to do a proper series on working with LOAD CSV and that kind of thing. So we're going to do that because you've all been wonderful. You've been giving me the kinds of things you want to know about LOAD CSV, so dealing with nulls and that kind of thing. So we're going to do a more comprehensive thing around that. But for now, we're just having a bit of a play with the data. So this is what we did last week. So this was a very brief write-up. Let me just pop the link in the chat for those of you who want to follow along. So here's the write-up. And what you can do is if you want to have a look at the data model that we worked on, and here's the video if you want to catch up from last week, what we can do is if you look here in the modeling, you'll notice there's a link here that says click here. So if I click on this, it's going to conveniently, let me just duplicate that tab. It is going to conveniently bring up the data model that we built together last week. Now, if you recall, when we were looking through, let me see if I make this a bit bigger. I'm just going to shrink it so that it's a little bit bigger. You can see the stuff. So if you remember, everything had the same state. And everything I think everything had the same establishment type as well. So I only had one node of this and one node of this. So in the end, what we did was we had entity connected to has operation type. So good so far. I think we're all up to scratch. So again, if you've got any questions about what we're doing, drop them in the chat. We'll pick them up as we go along. And so this was our data model. Now, the thing that caught my interest was, okay, we had a couple of things. So one was the address. So can we find businesses with different license numbers but at the same address? I thought that'd be a bit of fun to look at. And the other one was to have a look at square footage. So is there some interesting thing we can look at if we look at the square footage of the store? Now, I did this last week in a sandbox. I didn't extend my sandbox, so everything has gone, which is fine because this is a good opportunity for us to, together, if you're joining in, to try and load up the same data and then we can refactor the stuff together. So let's first bring up the data. So I've just spun up a brand new sandbox. I'm going to open this up in browser and I'm going to copy and paste all of the stuff that we did last week. So I'm just going to copy all of these indexes that we need to set. Get that browser fire up. And say hello. Say hi in the chat. It'd be interesting to see if we've got some regulars or we've got some new people joining in. Don't be shy. Okay, just wait. I'm going to say hi to Alex because I can see Alex is about. Okay, right, let's put in set the indexes and we're going to load some data. So I'm just going to copy and paste this. Hi, Alex. I am going to David. So I'll quickly talk you through what's going on here. Hi, Jobank. Thank you for joining us. Okay, so what have we got? And hi, Twitch Biz Coach. Yeah, you're welcome back. Isaac, thank you. Always good to see you. Isaac and Alex, we usually see you on Mondays. So let's talk about what's going on here. So if you recall from last week, I imported this data. So I dropped this into GitHub, and I'm just pulling this from GitHub. So I'm just doing the LOAD CSV. And what we're doing here, so this is that we did a couple of passes. So the first pass was to do the state establishment and operation. And if you remember, it was just the operation one that we had 80 something nodes. And the other ones, we had ones we didn't bother linking them, but I'm not going to change that. We can just copy and paste this and let that run. And we're then going to load up the establishment. So we're going to create the establishment and connect it up to entity type. Oh, did I remember the code? I'll have to dig the code out for that. So let's let that load first. And then we'll load the other stuff as well. And then we are going to have some fun. Right, so that's all loaded. Let's load up all of our establishments as well. And whilst that's loading, let's have a look at what I think we're going to do. So I think we can have a bit of fun with looking at the address details. Why do we want to look at the address details? It's a good way for us to do some kind of entity resolution. So I thought might be a bit of fun. Can we find some stores in the same location? So maybe you've got more than one business operating in the same address. So maybe this is a tower block or something. Maybe you've got shared offices. Just as an example, down the road from where I live, there was one place that used to have I think it was a Chinese restaurant. So they had all of various Chinese cuisine, and they had an eat-in restaurant. And obviously they decided that they'd stick to doing the takeaway part of that business, and they converted the restaurant into a pizzeria. So you can go and get takeaway pizza. So you've now got two different businesses operating in the same venue. So maybe we can spot stuff like that as well. So I thought it'd be a bit of fun. So where are we? So, oh, excellent. All of that data is loaded. So let's bring back some of these establishments so you can see what's going on here. Let's bring in. So not everything's got, oh, hello. Oh, yes, we didn't load the addresses, did we? Okay, so we're going to load the addresses. That's fine. So all we've done here is the identity. What did we say identity was? Let me remind myself. So the license, okay, so we should have, oh, entity, not establishment. Oh, what's going on here? What have I done? Oh, establishment type and entity. Okay, so we don't want establishment type, we want entity. So let me bring up some entities. So these are all of our various shops and such. So we didn't load everything in. So anything we loaded in was the name, the DBA name, which somebody told me last week what DBA stood for, but I've completely forgotten. I'll have to look that up in a bit. And the license number. So we've not brought in the address, which is great because we're going to refactor the model and talk about it. So we can have a different session where we talk about bringing things around. But let's talk about what we want to do. So I'm thinking we pull out the street address. So let me bring back some records. So I'm just going to borrow this and we can have a look at the address details. And return row limit 5. So we're not loading any data here. All we're doing is just going to pull and have a look. Yes, doing business as. Well remembered, Alex. So DBA is doing business as. So another fun thing we can do is have a look at how many have got a different doing business as name with the actual name. Well remembered. I know, every time I see DBA, the database architect, I think of database administrator whenever I see DBA. So that's like, that plays with your mind, doesn't it? These, they call them TLAs, don't they? 3-letter acronyms, TLAs. What's your favorite TLA? And you can't be TLA because that's taken. So, okay, so if we have a look, we've got in here. So we've got a street name, we've got a city, we've got a county, Erie. So I don't know how many of these are in, because these are all in New York, aren't they? So we're going to have different counties. So we've got some options here. So we could split out the county names. Oh, let's do that. So what I'm thinking here, so this is what a current data model looks like. And I'm wondering, maybe we should do something like this. So bear with me whilst I draw this out. Maybe we do something like, so this will be, actually, let me just grab a copy of this so I can remember what all our fields are. So we'll cheat a little bit, and I think we'll just stick with the address line 1. I don't think we're going to bring the whole shebang in. Okay, so I'm thinking we have entity has an address. So let's do address. And I think if we just stick with because we've got address, we've got here street name, don't we? So, oh, I can press the label. I keep forgetting about the label. So Isaac asks, is there a best practice for which types of information to turn into a node versus which to keep as a property? Great question. So let's sort of remind ourselves around the process of this. So this is very much driven on what question you're looking to answer. So when we looked at this last week, the question that we were looking to answer was how many establishments or how many entities do we have per state? So that was the kind of question we're asking. So how many entities do we have per state? And then we discovered that we only had data for one state. So a bit of a null question. But another question would be, how many different entities per operation type do we have? So if you remember operation type, so we can have a quick look here at the data. We have this code for operation type like JAC, and I believe it's a food place. So this is a food set data. So unsurprisingly, everything's got a J in there. And then you'd have other letters. So it'd be like, maybe it was food for animals, maybe it was food for humans, maybe it was a bakery was one we had. So here's the type. So maybe we want to have a look at how many different entities per establishment type do we have. So again, this kind of makes sense that we keep this, we keep these entities. Now we're changing the question here. So before, when all we were asking about was number of entities to state or entities to an operation type, then it made sense to keep all of this address data and the square footage inside entities properties. That completely made sense because we weren't asking any questions about the address. We weren't asking any questions about the square footage or the size. So that completely made sense to keep those all as properties on the node. Now we are back. We've got more questions, and the kinds of questions I want to ask here are, how many entities with a different license number? So different businesses can have a different license number, but how many of those entities are in the same, sorry, how many entities do we have per county? So we had Erie in there, and I can't for the life of me remember any other counties. New York County, maybe. So, I now want to look at number of entities per county. I now want to find out, do we have entities with the same address? I also want to have a look at some correlation behind the operation type and the square footage of the company. Now, you see, I'm now wanting to ask lots of questions off of certain properties. So I want to ask questions off of this county property. I want to ask questions off of this square footage property. I want to ask questions of the street name property. Now it's time, because we're asking lots of questions against these specific properties, to turn these into nodes. So now we're going to do this process of reification, where we pull out these items and it's like a property, standalone in the node. Now it makes sense to change that. So a very rough best practice is, if I'm never asking questions about those particular items, keep them as properties wrapped up. But if I find myself that I'm asking lots of questions, now is a good time to pull them out. Does that make sense? Hopefully. So that's what we're going to do now. And let's pull some nodes into properties. So I'm thinking here we're going to have an address one, and address is going to have I'm just going to stick with street name, because let's stick with street name and city. So I know this is a gross assumption, but I'm kind of going to make the assumption that street name, city for information value, and zip code should give us a unique property. So then if there's more than one street name, same street name multiple somewhere else, the zip code's going to be different. So let's do it for that, and we can always refactor it if we think it's wrong. So let's go with that. So let's have a street name, and let's have the city. We're not going to do queries against the city, but let's, for our reference, we can have a look. And if we do have queries against city, guess what? We can pull that out as a node if we ask lots of questions about the city. So it's all good. We have that flexibility. Yay. Let's do zip. I'm going to have that one as well. And so from here, we're going to remove those because we are having them as our... Oh, where is zip? It's hiding. And because I'm not doing anything address line 2 and address line 3, I'm just going to leave them there. Just they can sit there and that's fine. So the other thing we said, we're going to do county because maybe we want to have a look at county to entities. So let's pull that one out. That is going to be county. And we'll just put in property of name. Lovely. So, can I make this a bit smaller? Right, okay, so let's do this, and I'm going to get rid of county. And there we go. So now what have we done? Because we're going to be asking lots of questions about county in relation to entity, we're going to be asking lots of questions of address in relation to entity. It makes sense to pull these out because we're asking questions about, the relationship between these two. Maybe we're going to do address to operation. So maybe I don't know, maybe there's certain parts of New York State where you have lots of places selling animal food. And I'm going to assume that if we look in New York City, we should see lots of, sort of restaurants and bakeries and that kind of thing, more so there because it's obviously a big, vibrant city. So that's what I'm thinking we're going to do. So let's put in some extra bits and pieces. So we're going to put in index for county and address. So I'm going to use... Oh, this is a good question. Any reason why I don't attach county to address? Another great question. So let me pop this one up. So Alex just asked, why don't I do this? So I've got county like this. And what I could have done is like this. So let's kill this relationship. So that's a great question. And I could have done it like that. I guess I'm sitting here thinking from a optimization viewpoint because I was going to be asking questions of entity to county. So in that sense, it makes sense because the most performant way to answer that question is to go direct from entity to county. So just one jump. Now, if we were trying to do groupings, we could do it this way as around. So there's nothing stopping me from doing it this way as well. And it could well be, if we were asking lots of questions of give me the address, give me the county where this address is in, then that would make sense. If that was the most common question we're asking is give me the county. So we can do either or either. I guess I'm jumping ahead of myself here. And I'm going, well, we've got a zip code here, so that's going to tell us a unique thing. So maybe we can first. So it could be either way. There is no, that the right answer is going to be which question do you ask the most and gives you the most performant answer. But performance isn't everything. And if this logically makes more sense to you to have it like this, then have it like this. And you know what? For the purposes of this, let's keep it like this because this logically makes more sense if you're looking at the model. So there you go. Again, I'm not really given a definitive answer because there isn't a definitive answer. There is no such thing as the right data model. It's the right data model for you, that you understand, that you're answering the questions, and maybe there is some wiggle room for optimization. Okay, so I'm going to keep it like this. There you go. I love this user participation, how we, user participation where we change the data model on the fly. So it's all good. Right, okie dokie. So we're going to do this. So what we're going to do, so this one's easy. I'm going to create an index on county name. This one is Right, it doesn't matter too much. So we probably want to, I'm just thinking now, do I want to pull out the zip code as well? Because then we can do on zip code, because then we'd be doing zip to city. Oh, let me think this one through. I was going in there haphazard and I was like, oh, actually, hang on. So if we do, because we can do I forgot what the word is. It begins with a C, where you put more than one property in to create your index. And the word has escaped me. I've lost my ability to conjure the English language. So it'll come to me in a second. Oh, hi, Totalook. Thank you for joining us today. So let's have a think we're going to do. We will. So let's start with the county because we know what we're doing there, and then we'll have a think about the other one. Right. So let's do create index on county. I'm going to do county, not country. Names. That's a nice, easy one that we can go off and do. So let's think about the address. What are we going to do here? So I guess if we're looking at the same, so there's a part of me wondering whether we should pull out, although no, it's not, because street name and zip is that. So we want to do the sort of combination index on those two, because that's the thing that's of interest. So let's do that. I still can't remember what I'm gonna have to look it up in a second. It's gonna drive me mad. Beginning with C, type of index, we combine two different properties. There you go. If anyone can think it, shout it, because I've completely forgotten the word for it. Okay, so let's do create index. And that is address. And we are going to have, do we call it address? Address? We've got two addresses. Oh, street name. And zip. Okay. And then what we're going to do, because I was lazy and I didn't load the data last time, we can just leave it out. So we just refactored the data model and pull in the extra data. So what we're going to do is we are going to load the data. We're going to look up the entities by license number. So we're going to do a match on the license number because that's a unique property that we have. We are then going to do a merge on street name and zip, and then we're going to set. Oh, we're going to do a merge on create sets job, and we'll talk a little bit about that in a bit. And then we're going to do a merge on county. So I'm going to recycle this because it's always good to recycle. So the first thing we're going to do is match our entity. And we're going to do that on the license number. So that's going to be license number, and that's going to be row dot license space number. So that was that one. And then what we're going to do is we're going to do a merge, not an urge. We're going to merge our address. And remember, we have a composite, that's the word I was looking for, composite index. So we're creating a composite index. So this is going to be on street name, which is row dot. And for those of you who are wondering, why am I using these backticks? If you are pulling data from a CSV or anything like that, where you've got spaces or any weird characters and things going on, if you wrap it in backticks, you're basically letting the engine know that, you know, it's weird stuff and it's got spaces, because otherwise it will just sort of complain if you've got space. Go, I can't find that row header. But because we're wrapping in backticks, it knows there's like weird things going on. So that's why we've got the backticks in there. So street name, And we want the zip code in there as well. So that's going to be zip is row dot zip code. Okay, so we're doing that. And now, so just to talk a little bit about what's going on here. So the best practice when you are using merge, when you're especially when you think about when you're creating data, is you could do merge and you put every single property that you've got in there. But that's not a great thing to do, because what merge does is merge going to go away and have a look at every single record you've got in the database that has the label of, in this example, address. And it checks against all of the properties, and it will go and do that scan. Now, if you remember, we've just created a composite index on street name and zip, because we're saying that zip plus street name will give us a unique value for this. And we're saying that actually, well, here we're going to have lots of different cities and whatever else going on, but we're not doing an index on the city. So what we do here is do the merge. So this is going to say, well, these are the minimum things we need to define this node as being unique. And then what we can do is this on create set. So as soon as if this is the first time we're creating this node using merge, then here's a bunch of other properties we'd like you to set, but these properties are not necessarily things we're doing lookups on, or we're saying that define uniqueness, if that makes sense. So this is good practice for merge. So don't put all of your properties when you're doing a merge. Put in the ones that are the minimum criteria for defining uniqueness. And then if you need to set new values because you're creating this node, then you use onCreateSet. If you are looking to update a node that already exists, you've got onMatchSet. All good. Right, so this is, so onCreateSet, we're going to do city, and that's going to be row dot, I think it's just city. Oh, hello. I don't even need to use a backtick. Now, if you recall, we did have a lot of white spaces going on. So let me just quickly scroll down here. So you see I've got all of these white spaces. So I'm going to wrap what we've done in trim as well to clean out all of that white space. So we are going to do trim everything. If in doubt, trim, I think it comes to this CSV. Trim. More trim. And you can't have too much of a good thing, so we've got yet another trim in here. Okay, right, so on create set, I think I just need to do, this is wrong, it should be city, no, this is a dot city equals, sorry, let me, before I've confused everybody here. So what happens when we switch out from a match or a merge, then we go from, whereas before we had like our references and we use the inline and curly braces for properties, here we use the reference. So now we're going to do, well, we're using this reference that we've set in the merge, so A, and then we do the dot property name. So here, city doesn't exist, that's fine, it's going to create the city, and this is the value we want to set it to. Okay, and then we've got one more, which is the county. So I'm feeling brave. I'm going to have a go at sticking this all in one query. If it doesn't work, we'll use iterate, or we just do it one by one. So let's see what happens. I'm feeling optimistic here. So let's do merge county. And that is going to be name, and that's going to be row, oh, trim, let's trim. Row dot, is it just county? It is indeed. Lovely. Okay. And last but not least, we need to plumb everything together so we know it all exists. So if we go back to our diagram here, what we're saying is that an entity, more than one entity may be at the same address. So we're going to do a merge. So this is why we may have to take a step back and do this in several passes. So we're going to do a merge between entity to address, and there will definitely be many addresses to the same county. So we'll have to do a merge between address and county. Let's see how this works. sure it'll be marvelous. If it doesn't, we'll just step back. So it'll just say, too big. That's fine. Okay, right, let's do this. So let's do merge. Entity has address. Oh, I forgot to add relationship types. I should add those in a bit. Has address. Okay. And we're going to do a merge. Oh, I don't think it's going to like this at all, but it's so good. It's all fine. I'm sure it'll be wonderful. Has county count. Okay, I think we've got everything. We may need to chop this up into a few pieces, but I'm feeling confident that it will work. So let me just run that, and I'm just going to take a note of what we did so I can write this up in our part 2 blog post. Just take a couple of these. Again, if you've got any questions, drop them in the chat whilst this is whirring away. I'm going to give this about a minute, and if it's not loaded in a minute, then I'm going to split out the query. Oh. Okay, that's fair enough. Right, so we're just going to, so Lou's not going to be so lazy. I'm going to do it in phases. So let's do match entity and address, and then what we're going to do is merge the address, and then we're going to merge address to entity. So that should be relatively straightforward. So let's go do that. And then we're going to do the same pass with the rest of it. So we are going to, so we can skip the entity bit because we're interested in address to county. This is now going to be a match. Get rid of that. I'm going to merge. And then we're going to merge address to county, providing the original query runs. Otherwise, I may have to split it out even more. Oh, there we go. We are good. And the last bit, which is going to tie up address to county. Let's just grab a copy of this so we know what we did. So we have a question. Let me bring it up. So just copy paste these. Right, so we have a question here, which is, for indexes, I use Elasticsearch for index engine. So I think it really depends on what you're trying to do. So if you're doing like big text search, then yes, absolutely do that. So I think it depends on what's your use case. So let's say we're doing some kind of a combination of things where we've got a description. Let's say we've got description of each of the businesses, and the description's really big and legalese and whatever else. Then I can easily see where you would use Elasticsearch and that big text of body. But I wouldn't necessarily do it for here where you've got specific things. I don't think those. I can't think of a really obvious use case why you would do it on specific properties that you're setting. But if you wanted to do a search within a block of text, then yeah, absolutely. I mean, use the right tool, especially if you've got a huge amount of text that you're searching through. And we've got another one here, which is from Isaac. Can you give a quick 30-second explanation on why you're creating the indexes? Absolutely. Great question. So you notice we keep using, so the match is an interesting one, but merge as well. So let's talk a little bit about what goes on under the bonnet when we're doing a query or creating data or updating data in Neo4j. So let me come back to this model here. So what you've got, so if you remember here, we've got a license, we've got an index on license number, we've got an index here on establishment type, we've got an index here on county. So let's pick that as these ones. So what happens, we talk about Neo4j and why graph databases are so exciting is because it's really quick to do traversal. So what do I mean by traversal? So for me to find out what state an entity is really fast. I don't have to go off and do any kind of cross-matching or look at a mapping table or anything like that. I literally go, right, at my entity state that I've found, do I have a relationship coming off of it called in state? Yes, I do. Okay, I just follow that relationship and find that. And this is really fast. Under the hood, you have got effectively pointers. You're pointer chasing, and those of you who've covered it in computer science, that is like really, really fast data structure. You just charge through and find information. So you don't have that. Now, the thing we have to do before we're in that state where we just go, whoo, just chase down a relationship, we kind of have to find our start point first. So in this example here, we'd have to still find our start point of entity. And if it's an entity of a specific thing, so like of a specific license number, we have to find that. Now, if the majority of the queries that we're driving for a unique property, so in this example here, if I'm loading and modifying data and I want a unique thing to do that against, for example, license number here, and that's unique. And last week we did a very quick test to check that license number was unique in our data. We need to find a start point. And what an index allows us to do from a match perspective, if we didn't have an index, what would happen? So let's say we said, find the entity of license number 123, as an example. If we didn't have an index, for the engine to find the start point, it'd have to go and say, right, well, you've specified we're looking at nodes with a label of entity. So I can ignore all the other nodes. So I can ignore the nodes with establishment and operation and so forth. So I now have all of my 120,000 entity nodes. And if I don't have an index on license number, I now have to scan every single one of these 120,000 nodes to go off and see which one has a license number of 123. By setting an index, we're creating an index tree of this specified property of license number. So rather than having to scan 120 different node property labels of license number, it goes, I just go look at index, and you chase down the tree of the index, which is super fast because it's a data structure that's been designed in that way. And then rather than having to do a database scan of every single entity node to find out which one has this license number of 123, just go, I've got an index for license number. So I just go off, I have a look in the tree, do my index lookup, and there we go. And I found my start point, and then that's really fast. And then the rest of it, we do that following down we do our traversals and chasing down. So that's what's happening there. Now, same principle when we think about merge. So remember we had here a merge on county. So let's pick county as the other example here. So we've got county, and I've put an index on name. Now, if I was doing a merge on county, because obviously we're going to have lots of different addresses in the same county, if I didn't have that index in place, what would happen would be the engine would go, well, I now have to scan every single county labeled node and look at the name property to see if that exists. And it's okay if we've got a few nodes, but can you imagine as we get more and more nodes, it's having to scan every single time for every single node. So bearing in mind, we've got something like, I think we've got 120,000 entities, if I recall correctly. So you can easily see it has to scan. And as we're getting more and more of these unique nodes, it's having to scan every single one over and over again. That's like, we get to a situation where the query can take hours because of the amount of work it's having to do. But by having an index, and we've got that merge, and we've got an index to define what makes that node unique, it's super fast. It doesn't go off and go, right, I have to scan every single node. It goes, no, I'll go look at the index because I've got an index for that property. And then very quickly it finds the right structure in there. And then it's a quick, that node already exists, I don't need to do anything, or no, that node doesn't exist, I'll now create it, and then I'm going to append to the index tree to then go off and find that. So hopefully that makes sense. I think that was significantly longer than 30 seconds. I do apologize, but hopefully that makes sense as to why I'm picking indexes and putting them in certain places. Okay, so we have loaded our data. So let's take a look. Let's see what it looks like. So call db.schema, schema visualization. And what does it look like now? So we have got, so forget about operation and state because we discovered that those were everywhere. We're not so worried about that. So we've got establishment type, we've got entity, and there we go. Look, we've got address and we have got county. So let's have a look at all the counties that we have. We'll bring up 25 of them anyway. So, oh, look at that. So this is where I didn't realize there's an Ontario. I'm feeling brave. I'm going to double click on Ontario, and look, we've got at least 100. Oh, did it say 104? So you've got all of these addresses now connected to Ontario. So I really now want to find out how many. So just very simple, without any processing, how many entities? So how many addresses have got more than one entity associated with them? So I'm going to do this in Bloom because I'm going to be lazy, and Bloom makes this nice and quick. So let's start up. Right. Oh, check out my awesome password for Bloom. That is hilarious. I just find the generated passwords for the Sandbox so funny. So let's have a look. Oh. Do any takers? Anyone want to guess? Do we have any businesses with the same address? More than one business? Place your bets now. We must do. I'm thinking we must have a few businesses. Even like you may have ones that have closed down and then a new business is opened up in the same premises and they haven't updated the data. There must be. There must be. Generate perspective and let's have a look. So if you recall in our schema, let's get rid of that. So if you remember, we've got this entity relationship. So how I'm going to see whether we've got more than one entity with the same address is I'm going to do entity, address, entity. So a nice little palindrome pattern, as I like to call it in Bloom. So let's do entity. And let's do address. Let's do, oh, yes, we do. Look what Bloom's suggesting. So I think we've got more than one business at the same address. So let's bring them back. Oh dear. I have a feeling we've got quite a few. So let's have a quick look. What have we got? Quick question here whilst this is loading. Hi, Akil. So how can I create relationships between all entities in one state and map them together? How do you mean? Can you give us a specific example? Oh, I think I'm going to have to go back to browser for this one because I think it looks like it's going to be a crazy number of these. So I'm going to do a sanitized version of that query. So, Akil, if you can give me an example and let's have a look. Oh, yeah, all them. Oh, good point, Alex. I didn't even think of that. So Alex has pointed out there could be like some dense nodes onto relationship because you've got all of them at the same shopping mall. Lots of food places at the shopping mall. Good point. Let's have a look. Okay, let's do match the one entity has address. No, has address. Oh, come on, Linda, be helpful. Has address. Address. And then we'll go back the other way. Has address. B2 entity. Oh boy. I'm going to limit this. Five. Let's see what comes back. Oh, wow. Look at this. Look at this. Let me make this bigger. So I'm just limiting some of these because otherwise it's going to be crazy numbers. And what have we got? So we've got here Shoemakers, Jack and Daniels. We're going to have to bring up the types of these, aren't they? We need to load some data in to tell us the types. So we've got this group here. Accord Quick Mart. I think, yeah, I feel like we're going to have a look at where some of these places are. Street name, Sut Fin Boulevard, and you got 4 of them here. Wow. Okay. Let's see if we can find some big ones. So let me zoom this out. Let's rejig this query a bit and have a think about how we're going to do this. Let's do it this way round. So match A address has RE2 and I'm not really, that doesn't really matter. And let's do with A, collect E2 as entities, turn A. Let's return, I think we should return a bunch of stuff. So let's do A dot street name, A dot city, A dot zip, and do count entities as count order by count descending limit 10. So what we're doing here, I'll just quickly talk through what's going on, is we are matching the address. So we're matching all of the entities that have a has address relationship with address. Then we're saying with A, so this is allowing us to do some aggregation. And I'm saying, well, we'll take A, so we'll keep the address node here as interest. And then what we want to do is collect. So this collect is going to gather up all of the entities that are associated with this specific address. And we're just giving it an alias of entities. And here I'm going to return the street name, the city, and the zip address. And the count, so how many addresses are associated, so how many entities are associated with this address. And we're going to order it by bigger to lower. And I'm just going to take the first 10 biggest. Make sense? Let's see what happens. And you do realize we're going to have to bring up Google Maps. This is odd. Maybe I should do size. Hang on. Have I got the wrong one? Oh, that's more like it. So you do realize what we're going to, so I'm just going to grab a copy of this query so I remember what we did. So look at this. You've got a crazy number. 58 food relationships, sort of foodie-esque places are associated here. So I want to bring up Google Maps and have a look, and let's test out Alex's hypothesis that they're moles. So, okay, let's quickly come back. So I'm just going to come back to Akhil's question. For instance, few companies in a company are retired, few are still working, and few are new hires. How can I create a node with these 3 different properties? Oh, just read the rest of your question. And if I double tap on the retired node, it should give me all the retired nodes. Right, so it's a couple of things to do here. So one, this would be a modeling thing. So what you would probably do, again, there's lots of ways to do this. One approach, maybe you would do a versioning, use versioning as part of your model. So you may define you may differentiate between a current employee and a retired employee based on whether they're still working at a company. So you might do something like employee works for company, and then on that works for property, you might do something like from. So maybe they're working from January. So from January the 1st, 2021. And then when they stop working at the company, so let's say they stop working today. So 15th February 2021. And then you might say that anyone who's only has a from date and has no to date, you could write a query to filter those. Another approach might be, well, actually, no. When I say retired, I mean literally they have left the workforce completely. They've turned 65 and they're now going to go off and not work anymore. They've had enough. They're retiring. They're taking their pension. They're off to pursue their hobbies. Then another approach you might look at is, well, actually, I'm going to add labels. So I've got a label of employee for everything, and with Neo4j, you can add more than one label. So you might say, well, actually, what I want to do is I want to apply a retired label to my employees. So not only do I have an employee label, but for some of my employees, I also have a retired label. And then you would change your query to reflect that. So you've got a number of options you can do that. And definitely, I think we're long overdue a modeling session on handling versioning. So we'll have a go at one of those in one of our live streams. But hopefully it's a very quick view that's going to help you. But you can't double click on it straight out of here. So you can either do it in Bloom and you navigate the data model that you've created, or you write a specific Cypher query. So hopefully, Akhil, that's helped answer your question. Now, I don't know about you. I have to find out where these. I need to know this Liberty Ave place. So give me 2 seconds whilst I bring up a Google Map. Okay, so let me put in this zip code and let's see what happens. So I bet some of you are even quicker. Yeah, let's do this. So we did say Jamaica. Ah, look at that. Oh, you're very welcome, Akhil. I hope that helps. And versioning is great fun. Look at that. So what did we say the name of this thing was? We said Liberty Avenue. So it's not even in Jamaica, but I assume this is all in the same place. And this is Richmond Hill. Oh, look, Liberty Avenue. There's our street name. So it's not a mall, but it's actually an entire street. So I think we've lost a bit of detail. So let's have a quick look at location. What did location give us? Maybe we need to add a bit more data in here. Oh, no, not all of them have locations. So it's hit and miss whether someone's provided us with that data of location. But there you go. So you can see we've got a bunch. We've got all of the food places down here. Yeah, so some of them, if I bring up the data, so let's have a look at this one, because I don't think they've provided us with, not all of them have got a street number. So let's have a look at, let's go the other way around. So let's do by ascending. So I'm just getting rid of this and let's limit 10. But some of them they do. So this is where we've got the funny data, because here we do have a street number. Again, I've got another one here, Cemetery Street. I wonder if there's a cemetery on Cemetery Street. So not all of them. So we might have to do a bit more digging around the data and see if they're hiding in the street number. So let's do this. Let's bring back. Well, let's take that zip number. Let's do something highly unscientific where we're going to look at the LOAD CSV data again and let's bring back some information. So let's go. There we go. Let's take that one. So where row dot, let me just remind myself what the license. No, we want zip code, don't we? Where row dot. Oh, famous last words. Let's see what happens. So this is me doing really lazy data investigation. And that wasn't too painful. That was pretty fast, wasn't it? So look at the Liberty Avenue. So what have we got here? Ah, so look at them. Some of them have put in. So some of them have got location for null, and some of them have got the address in the street name. So I guess what we can do, let's reprocess the data. And this is where we can use, we're going to do two things here. So the first thing we're going to do is so I'm going to keep it in street name. And what we're going to do is we're going to reload all of the addresses, but I'm going to use a coalesce. So I'm going to coalesce location with street name. I know this is really messy and unscientific, but we'll just do this for a bit of fun to see whether or not there's something weird going on here. So if we coalesce the two, hopefully we should get a... I'm going to do two things. I'm going to do a contain. So if street name is contained within location, then I'm going to take location. If it doesn't, then I'm going to take street name. So let's rewrite the whole thing. And how are we going to do this? We probably want to get rid of... We're going to get rid of the stuff we just put in, and then we're going to redo it again. So let's see how many addresses do we have? Okay. All right, I'm going to live dangerously here. Let's do match A, attach delete A. Living life on the edge here. I'm assuming that we haven't got a huge number of dense nodes. It will complain if it does, and then we can use periodic iterate. So let's redo the address query whilst that's whirling away. So what I'm going to do is the following. So I'm going to say match entity. Good. And let's just think this through. Oh, I'm just going to be lazy. I'm going to... Do I want to coalesce a lot? Oh, let's do this. Match entity, merge. And I think what we're going to do here is we're going to say trim, coalesce. Yeah, let's try it this way around. Let's do row dot location and row dot street name. What we're saying, I'm making the terrible assumption. I'm taking all the blame. I'm making the terrible assumption that if a location doesn't exist, then the street number as well as the name is in street name. Otherwise, everything's in location. I could be completely wrong, and I've misspelled location, so I'm not going to win here. Location. So row.location, otherwise row.street name, zip code. Right, okay, so let's replace all of those. Oh dear, what's happened here? What did I do wrong? Match. I thought we got rid of... Oh. Let's see what's going on. Did I misspell location? Location. No, that's correct. Ooh, this is exciting. Let's see what I've done. It'll be something obvious. Did I spell location correctly? Number one. I did. Right, maybe I'm being a bit lazy and I should do it this way around. So and get rid of this. Maybe it needs to be that way around. Let's see what happens. Oh. Huh. What is going on here? Right, let's do a... Oh no, some people have put corn nuts in as well. Oh. Yeah, we're not going to do a whole piece on data cleaning. I just want to find some places that have got the same address, and then we're going to call it a day, and we've had a good bit of fun. So let's have a look. Oh, dear me. Why is... Let me get rid of county as well, just in county, just as... What's going on? Oh dear, everything's disconnected now. Hey. What did I delete back? Did I delete something that I shouldn't have deleted? Oh. You know what I've done? I forgot to put in a colon address. I've deleted everything. I've deleted the entire database. That's okay, because we know how to load it up really quick, so it's all good. I accidentally deleted all of the data. That's why nothing was working. Don't do that. Be careful with it. Be careful how you use Mac to touch delete. But that's okay. I'm just going to copy and paste a bunch of stuff, so we're all good. Oh dear, that was careless, wasn't it? That's fine. We found the problem. Easily solvable. And let's bring up the next one, which will now work because we have some data to load. And I guess we can go crazy and put in the... Oh, no, there we go. It's loaded. And whilst that's running, we can do the next part, which is going to be match. So this we can get rid of. The match on this. And get rid of that bit. And let's just copy the bit I had from a previous one, which is merge the county. And then merge the relationship between address and county. Oh, good. Okay, cool. I'm super excited to see what comes out of this. So give that little chance to go. And yeah, we'll be able to find that shopping mall. I need to find the shopping mall with all those food places there. If you've got any questions as we wait for... Oh, window of opportunity. Well, still ask your questions. I'm not going to stop you asking questions. But that was a perfect loading opportunity. Welcome, Linux Pavio TV. Okay, so got load up counties in, and then we are good to go. Hey, right. Time to re-ask that question. Luckily, it's a copy and paste job. We did this earlier. Oops, no, I don't want to save. Right. I'm dead excited. Hey. Oh, All right, let's check this out. Let's find out this place with 21 food stores of various descriptions. Let's do this. Oh, there's what this was Flushing Avenue. Right, is that like tennis? Oh. $630. Hang on. 630. Oh, that's exciting. So we're going to have a look at what all those buildings are. So let's have a quick look. What have we got? So Isaac asks, does Neo4j have a service where we can share our data models and main queries or use cases and then get feedback on how to increase performance? So two ways of this. We've got the community. So we've got Neo4j community who will, you post stuff up on the forum and our lovely community can come and help to some extent. If this is more of a business slant, then we do have professional services and they can help you with that. And absolutely professional services can come along and look at your data model and help with those queries and find optimization. But that is a paid for service. So you have both options there. So if the latter is what you're interested in, give me a shout and I can put you in contact with people. If it's more of a get sort of community help, then you've got the community forum that can help with that as well. So you've got the two options there. Okay, so I don't know about you all, but I'm really intrigued now. So I got dub pies. Is dub pies in our data? Should we have a look for dub pies? So going to look for dub pies now. So let's do. How are we going to do this? Actually, let's do this one in. Let's do this one in Bloom. This one will bloom nicely. So let's just reload the data. Oh, I should have an option here to. Yeah, that one. Okay, so dub. This is being a full text search, so maybe we should do this one. So 630 Flushing. Oh, it's all capitals. Hang on. Okay, let's bring this up. Oh, we've got 3. I bet you what's happening here is that not all of them have got the Flashing Avenue. Let's not even go into the data quality thing. There are ways we can fix this. That's not for today. This is just us having a play and refactoring the data model and importing some data. But which one we were looking at? We were looking at Flashing Ave, Brooklyn, NY. That's not that one. This one. Okay, right. So let's going to dismiss the other nodes. Oh man, are we going to find dub? All right, let's quickly change our perspective so that we have the entity name. Can we find dub in here? This might be an old data set. I can't see in here. Let's see if we can find the other food places in here. So we've got. Is that a food place? Yes. Do we have a red velvet in here? I bet it may well be in the other ones. We had all of those other ones going on. So let's bring back all the flashing have ones. So let's do street name 630 flush. Yeah, so let's bring them all back. Let's bring up all the entities. Surely we're going to find them in there somewhere. So we've got in here. Legally addictive foods. I hope they're selling chocolate, because otherwise I'm a bit concerned. What else have we got in here? So this one is sweet and salzig. Should we just cheat and put in sweet and salzig? Let's do that. Do we have to bring in the other trading names? Sweet and Jack. Okay, let's look at that one. Jack Zig. Interesting. Okay, so they've changed their name yet again. So, we're having a field day here, aren't we? Cromwell Bake Shop. Oh, let's see if we can find Cromwell Bake Shop. Can we find it in here? Pippin Bits. Oh, look, there we go. There we go, we found it. Cromwell Bake Shop. There we go, we found some of those in there. So I think why we've got loads of them here is because you've got this Pfizer building, and it looks like they've got loads of eateries inside the Pfizer building. So let's have a look at another one. Let's have a look at, I'm just going to copy this address here. It's probably the quickest way to do it. So this place has got 18 eateries. Let's go have a look. Yep, so it's another one of these sort of block things. And let's find Mighty Monkey Bakery. Let's go find Mighty Monkey Bakery. So let's go the other way around here. So let's do entity name. Let's just clear the scene. Let's get rid of all this stuff. Oh no, something else. I think the data set might be a bit old. But anyway, you get the idea. So let's have a quick summary of what we've done today. So what we did, so originally we just had the entity to establishment to operation to state name. We decided that actually we wanted to ask a few more questions. So we wanted to find out, were there lots of entities at the same address? And the answer is yes. And that's because, as Alex has identified, we've got malls and that kind of thing going on. We did look at counties. So let's just do a last query where we're going to have a look at which count. Let's do the distribution of the most number of entities to county. And then we're going to wrap up. And we had a nice bit of fun here. We've looked at reiterating this. A part of me is really tempted to do the data cleaning on this. We're not going to do that because I'm sure we can find, well, maybe we do. We'll figure it out. If there's a great demand, then I'm sure we can do a data cleaning run on this. But we're just doing a bit of exploration. So let's do the last query, and we're going to find out what are the most popular counties for these food establishments. Let's do match the entity. And we've got has address. We're not too worried about the address. That's just our pass-through node, and the address has a county. And let's go to see county. And then what we're going to do is we want to with C, and let's do collect. Is that the right? Oh, hang on, we've got to be careful here because we've got. Oh, thank you for joining, Renan. We'll see you later. So let's look a look here. So the only thing to bear in mind is, oh no, it should be fine. We've got multiple entities to address. So the only thing I'm worried about here is that we might have lots of crisscrossing because we've got an address to. We have multiple addresses at a county, but I think it should be okay. It fans out. So we'll do a quick check. So let's do it this way around. So with collect entity as entities, and let's do return c.name size entities as count, order by count descending. Let's see what happens. So I think this, let's just put in just in case. Check that we get the same values. Yeah, it's the same values. That's all good. So we don't have a crisscrossy problem. So the most popular place is Kings, followed by Queen. I love that. Kings and Queens, followed by New York, Bronx. I think all of these are bits within New York City, aren't they? You can see all the popular ones. So unsurprisingly, all of the big areas in New York, they've got loads and loads and loads of these food retails. And then let's look at the bottom. Hamilton, Schuyler, Lewis, Wyoming, Yates, Orleans. These have all got very relatively few places. So I guess some fun stuff could be to have a look at the types of eateries in there. And not eateries, food retail outlets. Not all of them are eateries. Some of those are suppliers of food goods. Some of them are supplying pet food, that kind of thing. But there we go. So we have a nice bit of fun. So by refactoring our data model, we've been able to make it relatively straightforward about how we can find out the number of entities at the same address, and also which counties have the most number of entities. So we've done that by refactoring the data model because we changed the kinds of questions we were asking. So there you go. So we're going to wrap up there. Thank you very much for joining me today. It's been good fun. I love doing these sessions. If you've got any questions, I'm going to hang around a bit. So I don't know if I get the messages if you're on YouTube. If you're on Twitch, I'm going to hang around for a few moments after I stop the stream. So if you've got any questions, drop them in. I'll pick them up. Otherwise, see you all next week, same time. Oh, sorry, normal time, same place. So 4 p.m. UTC. So that's 8 a.m. Pacific. 8 a.m. West Coast, 11 a.m. East Coast, 4 p.m. UTC, 9:30 Indian Standard Time. So I'm going to work through all those time zones. So see you again next week, and we'll have lots more fun as usual. Have a good one. Have a wonderful week. Bye.